Hi class, welcome to lesson 13. Today we are going to find out how pressure influences a phase change. Our goals for today are to define vapor pressure, to interpret table H, and to establish the relationship between vapor pressure and intermolecular forces. Make sure you're taking notes. So when we think about phase changes and pressure, we know that the only phase of matter that is affected by pressure is the gaseous phase. From personal experience, you should know if we take the stopper off of these flasks, the liquids inside each stopper should evaporate. But since the identity of the liquids is not the same, they are different chemical formulas, so they should have different properties. That means they will not evaporate at the same rate. The rate of evaporation is related to something called vapor pressure. Vapor pressure is the pressure above the surface of a liquid as it evaporates. Vapor pressure is influenced only by temperature and the nature of the substance, meaning every substance inherently has a different vapor pressure. The vapor pressure will change as temperature changes. Vapor pressure does not depend on the amount of substance present. If you've ever washed your hands with hand sanitizer versus soap and water, you know that ethanol, or the alcohol present in hand sanitizer, evaporates faster than water. When a substance easily evaporates, it has weak intermolecular forces and a low boiling point due to its high vapor pressure. Remember, vapor means gas, so if you evaporate easily, you easily make lots of gas. Versus water has exactly the opposite properties. Water has a low vapor pressure, which makes it harder to evaporate due to its strong intermolecular forces. Forces holding water together as a liquid are very strong and difficult to overcome to turn it into a gas. Water boils at a higher temperature than ethanol due to its higher intermolecular forces. It is important that you understand that when the vapor pressure is equal to or greater than the atmospheric pressure, a substance will be boiling. The boiling point is defined as the point where vapor pressure exactly equals atmospheric pressure or air pressure. Reference table H gives the vapor pressure of 4 liquids at various temperatures. Notice that as temperature, or the X value, increases, so does the vapor pressure. So as you increase temperature, vapor pressure increases. This should make sense, as water and other substances evaporate faster at higher temperatures. The term normal boiling point is the temperature at which a substance boils under standard pressure. Standard pressure is defined on reference table A as 101.3 kilopascals or 1 atmosphere. Notice that reference table H lists pressure in kilopascals. You can see that ethanol, when the Y is 101.3 kilopascals, the X is 80 degrees Celsius. Therefore, the normal boiling point of ethanol is 80 degrees Celsius. Take a moment to examine Table H and answer this Regents question. The question asks, as the X increases, what occurs with the Y or vapor pressure? In this question, they ask about the curve for propanone. Make sure you're looking at the curve for propanone. Here, they have given you the X value of 45, and they want you to determine the Y value. Pay careful attention to the fact that the X value interval is different than the Y value interval. Find the 4 coordinate points and find the lowest vapor pressure. Remember that vapor pressure only has to do with the nature of the substance or its intermolecular forces and temperature. Those are the only 2 factors that influence vapor pressure. Using the given X values, find the substance that has the greatest Y value. Which reason best explains why water has a higher boiling point than nitrogen? Water is harder to boil or change from a liquid to a gas than nitrogen. This concludes Lesson 13. Make sure you come to class with any questions you still have.